This is the no-till. Now notice that there is some soil, but what's happening there? It's holding together a little bit better. Okay. And those are aggregates. I've got a little sample over here. I don't know, Charles, if you can find it. It's over on the table over there, in the little blue. We'll show them what the aggregates look like. Staying in bigger chunks. What's happening on the left here? It's basically just disintegrating. Okay. Here's what's happening on the right, and I'll pass this around. These are the aggregates that are falling apart. They're still somewhat, they're aggregated because of that soil glue. And so there's just an example from this soil where we've taken it, let it dry out, and put it on there for you. So what happened? There's a couple of things happening here that are important. One, there we go. There went some. It is falling apart. But some of the main things that you would work with your students on is there's a little question exercise here at the end. Did both samples react the same way? No. Did they stay together or fall apart? Well, they're both falling apart somewhat, but this is still staying aggregate. So you can imagine this soil here, we had water come in it. It still has some of that pore space, okay? So you can kind of see here, this is basically totally fell apart.
You said the only difference was conventional versus...
Yeah. Yeah. Here just, that was a good question. The question was, what's happening with, this is a little different texture, but I'm going to go ahead. This is a conventional till soil that's got high organic matter. So in different words, it was one of them below Branched Oak Lake, some of those fields that pretty high in organic matter. But we'll see what happens and kind of compare that. This is tilled. So what's happening there? It's a little quicker than the no-till, right? But it still has some good aggregate stability because why? Natural organic matter. Okay? So you can kind of see a little bit of difference that the management does for you versus some of the natural fertility there. Okay?
That's just water.
Just simply water. So what the idea here is with your students that you can go ahead and you could set this up. The instructions are in this little handout that's in your section 5. And then what I did to facilitate this, I've got enough of these for everybody that we'll have out here. When you leave, go ahead and gather them. So you'll have the screens, and all you have to do is just get a container. It doesn't have to be like these. They can be glasses. They can be anything. So whatever you want. Okay. Okay. The next one we have here is called filtration. And we'll get some more volunteers here. One on the right, one on the left. What I did here is I just put food coloring. We'll go with Steve and Mark. And you can go ahead. You can fill these about halfway up with the colored water on each side. So you notice I've got, that's good, and some on that one. You notice I've got a couple things going on. I added more containers here so you can increase the number of containers. I've got different textures of soils, and you can compare different soils and what happens. The educational goals here is to demonstrate how soils clean water. Okay. And one of the main education goals. What's happening with this one right here? If you can take a look on the front side here, is the water dirty or clean?
Water's
Pretty clear. Why do you think that is? This is a silty clay soil. Okay. Okay.
White colored water.
Yeah, it has much more surface space. It takes longer for the water to enter it. So it's got more what? Exchange capacity, more surface area. So what's happening to the food coloring? Yeah, and I could keep running this for a long time, and it's eventually you're going to get all of your exchange sites, your cation exchange sites saturated, and you'll start getting some color through. Okay? So we look over here on this one here, is it change color a little bit? So I've got kind of more of a loam soil, and it's what's taken what color out of it. We got green water, it's coming out almost either light green or yellow. So it's kind of taken the blue part of it out. So what's happening here is it's doing its job of filtering, but it's not as much filtering as the silty clay texture soil. So you end up with more of a yellow water. Let's go over here to this one right here. What do we got going here? Got the blue. So what did it filter out? Filtered the yellow. So I don't know. This would be a good science project, but what's happening here again? This one is actually the soil. I only have 2 versus here I have 3 bottles, but it's filtered the yellow out. And I suppose again, eventually here, if we waited long enough, that green water would come out if you keep doing it long enough. Okay, and then what's happening on this one? Is it going through it all? Just dripped. So again, that's a pretty tight soil. So it doesn't really have. It's going to be clear water on that one. Okay. So what properties do you think are influencing again with your students? What would you ask them? What properties are influencing what's happening here? Percent clay, the texture, pore space. Okay. So exchange capacity. What's happening with the colors of soil here, or the colors of water that's coming through? So once all those become saturated, then you're going to not get as much filtration. What about surface water or groundwater quality? What's happening here? Which one of these soils are you going to have to be much more careful with, as far as either chemicals or nitrates or sulfate that might leach? The sandy soils. So the other thing is, the more depth you have to groundwater, the more filtration capacity you have, the more texture you have, the sandier isn't going to filter as well. From the runoff standpoint, this one here might have what? More runoff. So you've got different management considerations. Some of the no-till, some of the cover crops, the good crop rotations. So you've got 2 things. One is groundwater concerns, 2 is surface water. So we're kind of demonstrating both and thinking through it so that your students understand that there's a difference. As far as your nitrogen management, how could you show this is important?
Which one's going to keep it the root depth?
Right. And John mentioned earlier that the soil that's saturated, he had those rows in that ridge till that were saturated. You didn't have the good aggregates. What happened to his nitrogen there? He lost it from denitrification. Yeah. Yeah. Okay. So one of the things that you would do, again, just kind of reiterating, is recognize that water flows through certain soils faster than others. You can predict the outcome of color water flows through a loamy or sandy soil versus one that's mixture of, it has more clay on it. Questions. What will happen if I add more stacks, more bottles?
It should clear it out.
It'll clear it out. It gives it what, a longer period of time to filter? Okay. So if we're designing a septic system, kind of put your engineering hat, is this going to work real good for a septic system? Not too well. So, but if you have pure gravel, you're not going to filter any of the pollutants out and those types of things. So that's where you get into some of the designs of septic systems. So if I add fewer filters, basically it's time and the type of soil, whether the cation exchange capacity that's going to impact it. By adding more bottles, you'll be able to do that. What will happen if I add water more quickly versus get a nice slow rainfall?
You're gonna have runoff.
You're going to have runoff, but in the soils that take it, you're going to put it through faster versus if I just added it slowly, it's going to do a better job of filtering than if I just fill it all the way to the top. So you can actually demonstrate that with like a sandy loam where I would add it much slower, have the same soil next to it, but just by the rate, you can also impact it. If the water comes out of the soil does not match the color, what's the reason for this? Why doesn't it match the color? And this is, again, the bottles they dumped in here is just food coloring, green food coloring. So why doesn't it match?
Some are easier, your colors were easier attached to the particles with
Right.
Some ionization.
Right. And this one, I used this in North Platte, and I used it a couple times before. It actually was yellow at one point. Now it's starting to get more, so it looks more like green. So what's happening? The one in North Platte, if we would have videoed this was about pure yellow. Okay, on this, we can pass these around so that you can take these. This is a good little project. If you want to use these, just pass those around. You can put here you go. And what I did is, yeah, what I did, if you notice on these, there's a screen on the end of all of those. I'm going to ask Charles to come in here and demonstrate this, but we brought these little strips here. Yeah, and they can get them in a second. So what we want to do is grab one of those bottles, Charles. See if I take it off. So what you need to do when you go home is each one of the bottles is take these and you'd put the rubber band around it like this. That's what those have on them. And then you'll create that screen. So you'll see just a rubber band with the screen. So this is the mesh that we use. Otherwise, it's going to take the soil and contaminate the next one. So you have to put the screen on it. Okay.
So grab a screen when you grab
So we will have this stuff up here. So if you want to, probably one of these is enough to do about 3 bottles. Okay. It's very small. Not sure of the screen door size. Yeah. Okay, very good. But you can see that there's different ways to do this. Some really good things that you can teach. Lots of the physical and even chemical properties. A lot of the different information about management. What we're trying to drive home, me as an agronomist, is the type of management I need to create, this situation versus one that we're going to have more erosion, more runoff, etc. And these are things that the students can put together. They can take these to middle school students, whomever. They can do a lot of this information on their own. And so, to me, a picture is worth 1,000 words, okay? Compared to just talking about it, me showing you some slides. You get hands-on, you get a lot of interaction and why is this happening. And they can gather soils, and they can gather soils from different fields with different management. You can do lots of different things in here and working in what's going on. I think that's all I have. I think about my half an hour is up, so I appreciate your attention.